I've been in the automotive industry for quite some time, and before that I was in the computer industry. And kind of the joke back and forth between them was the computer guys always said, oh, we innovate at such a faster rate. And the automotive guys are like, yes, but if you get the blue screen of death at 80 miles an hour, you literally are dead.
Hi, I'm Shawn Luke from DigiKey. Here with me today is Kirk Ulery from Molex. Really excited to have this discussion. Kirk and I have known each other for a while. We've had some conversations back and forth around transportation and interconnect. Just delighted to be here today. Kirk, how are you doing today?
I'm very well, Shawn. Thanks for the introduction. Again, I'm Kirk Ulery. I'm a distribution business development manager for Molex, based in our transportation systems business unit.
Yeah, you've been just a wealth of knowledge around interconnect and the transportation field altogether. Looked you up a couple of months ago and saw that you had a whole series with Molex called Beyond the Garage. It seemed to just really fit in with stuff that we've talked about in the past. We'll put links down in the description for viewers to follow along. I'm curious, in your own words, can you tell us kind of what Beyond the Garage is and why you felt the need to go forward with this series?
Yeah, certainly. I'm out of our transportation systems business group, and the reality of that is everything we've designed has been for automotive. My focus is working with distribution partners like DigiKey for those non-automotive applications. And we're trying to come up with a way to get people to think outside of that automotive. And we went back and forth a couple of times and finally came up with that idea of Beyond the Garage. So even though our parts were designed for cars that are in the garage, my focus is for applications that go beyond the garage. And that's where the genesis of that idea came from. We currently have what we call jokingly season 1 that are already up on YouTube. And recently we filmed another set of series that'll be released throughout 2026.
Excellent. And I'm excited to see those. Was there a certain application that caught your attention? What was something unique that gave you pause?
Well, as I go through this, I find more applications every day that really excite me about where we can go from there. One of the things we do with the series is we talk about why we developed it to do what it does and about the specific environments that a vehicle has to go through. And then as we go beyond the garage, we encourage people to think about whatever they're designing and what their part has to go through, and then think about why our parts are a good choice for that. The biggest one to me is our first video series we did was on our MX150, which is a mid-current, mid-voltage system that's used all over automotive. And it's actually the largest global Molex product line. Well, we currently sell that to an appliance manufacturer who uses it in an industrial dishwasher. And the value proposition is they were able to seal the control board of their industrial dishwasher using the MX150 and the fact that it's sealed against all the things that your car goes through. So if you think about an industrial dishwasher, which has to run all day in a restaurant, typically 7 days a week, if a hose happens to break inside the machine, all that happens now is the outside of the box gets wet. In the past, they had a bare circuit board, and when that circuit board got wet, you ended up frying components. It was a very expensive repair. So that's the value proposition for that specific application.
That's really a good one, because thinking about a dishwasher altogether, you've got heat, you've got moisture, you've got vibration. You know, these are the type of things that engineers are dealing with as they're designing different systems. We hear rugged sometimes is one of those words that gets put out there. How do you define rugged?
For us, rugged, again, has to do with the environment that your system goes through. The same MX150 that we use on internal combustion fuel injector modules also works for anti-lock brake calipers, which are mounted to the wheels. And as we're recording this, it's wintertime, and we've already been talking about snow. Think about what your wheels go through, and your anti-lock brakes continue to work throughout that entire environment. So that's the rugged piece of it. And then, since I also live in the Detroit area, potholes are a major issue for us. And again, thinking about how your wheels bounce up and down as you go along, those are the types of environments that our connectors are used for. If you're doing things in the construction industry, any type of material handling, those types of things. We have connectors that will meet those environments based on dozens of years of vehicle experience.
Do you have some examples of other industries that require rugged connectors? We just talked about transportation. You mentioned home appliances. Just curious if you have other fields that come to mind.
Yes, agriculture is a great secondary market for us. We supply products today to most of the large farm equipment manufacturers in North America and throughout the globe. In the construction industry, you have backhoes, forklifts, those types of things that, again, are subject to some very harsh environments. We're moving into other market segments like marine. And again, getting into a boat, there's water always. If you're on a rough lake and you're moving at any kind of speed, the boat tends to bounce around. Those are the types of rugged environments that we want people to use our products for.
One thing that we see in transportation altogether is the shift to 48-volt systems, where some of those transportation systems have been at 48 for a longer period of time. We're definitely seeing automotive go to that 48-volt power rail. As designers are looking at considerations of creepage, clearance, other materials, what design considerations should designers be thinking about with that 48 volt?
The biggest thing for us at 48 volts has to do with what you just mentioned, the creepage and clearance. We need to make sure that we meet the specific standards organization requirements. Creepage has to do with how the voltage can go across the plastic, and clearance is the distance between two pins. So that's how we define that. And there are specific requirements for the distance to make sure that you don't have arcing between the pins. Most automotive systems are designed for 20 volts or less, and the creepage and clearance for those systems is not really a consideration. Getting up to that 48 volt, or as we call it, mid voltage, so it's anything between 20 and 60 volts, we have to make sure that there's some clearance there. I've experienced that myself. I have an electric pontoon boat that has a 48 volt motor, and I switched my battery out this year from 4 12 volt batteries to a single 48 volt battery. And I noticed immediately that if there was any kind of load, I got spark just trying to connect the mounting bolts for the power rails. So there are a lot of different considerations that have to be there. Speaking of the arcing, we're very concerned about hot plugging with our 48 volt systems. We make sure that we have the proper platings to withstand that arcing. Typically, when we get into the very high voltage or anything above 60, we use silver as the plating material. It's much more forgiving during the arcing. But from a cost standpoint, we still use a lot of tin plating for our interfaces. So we ask people to be very considerate of if they're going to hot plug the system. We also have some systems that offer a make first, break last for an unpowered system, so the power doesn't come up until those two pins go together, so it knows that everything's there. And the other thing we're seeing with the 48 volt power rail is the advantages are becoming significant as we see more and more electrification. And when people think of electrification, usually they think strictly of an electric vehicle. But even in the automotive industry, we have internal combustion engine systems where the manufacturers are electrifying things like power steering. We're seeing electric turbocharging. We're also talking to a couple companies that are looking at electric brake calipers. So anytime you take a mechanical system and electrify it, for us, that's what we talk about with electrification. When you increase that voltage from 12 volt to 48 volt, you increase your wattage by a factor of 4. It goes back to the old Ohm's law. And even if you're not increasing the wattage, the value proposition we're seeing in automotive is that they're able to reduce the current. A typical vehicle today at 12 volts requires about 80 amps of current for the entire power rail. If you go to that 48 volt, you can drop that to 20 amps of current, which allows designers to use smaller terminals, smaller wires, and the smaller wires are way less, they cost less, which is always a factor, and they're much easier to route.
Yeah, it's a huge value proposition as you bring up. Like by increasing the voltage, if you're going from 24 to 48, you're passing half that current then. It's just that quick back of the napkin calculation. And with that, you pointed out super valuable points, the weight of it, how many wires you're putting through a conduit, so on and so forth. And So cost is coming down, weight is coming way down. One of the things that I'm thinking about is just the crazy amount of data that is going to go into more modern transportation. As people are pushing into a place where they're trying to get to autonomous driving, we see so much of like computer vision. We see more sensors, largely in the way of like cameras and stuff like that, are pushing massive amounts of data. Stuff that we used to think about as like the trunks for network are now getting implemented within transportation systems themselves. It's kind of wild to see this idea of, it's almost like a data center on wheels when we think about some of the transportation systems being developed, because you've got these full capture sensors, image sensors, just pulling in information, and safety is so critical that it has to be quick, and we need multiple cameras going at a single time. Like, what innovations and connectors then can those design engineers be looking for to help them maintain, signal integrity and bandwidth of all the data that's coming through those data channels?
Yeah, we actually have two distinct areas that we're focused on for these applications. The first one is Coax, and digital cameras in cars have been using Coax for about the last 10 years. The US government mandated backup cameras in 2015. And the initial cameras were analog, and you typically needed 5 or 6 individual pins for that analog camera. You had the different colors, power, ground, and some type of a sync system. Well, if you go to power over coax, where the receiver actually sends a low frequency power signal to the camera, which has enough wattage to it to turn the camera on, and then the camera sends it high frequency back to the receiver. So it's a single coax lead that plugs in. And automotive manufacturers have used FACRA as a standard. It's a German acronym based around the old SMB connector that's literally been around for about 70 years. But over the last 5 or 6 years, we focused on mini FACRA, or HFM is the Molex product. It's high-speed FACRA mini is what the acronym refers to. It's a smaller system, and it also offers you option for multiple pins in a single housing. When automakers learned that they had to do a backup camera, it wasn't very long before they came for the surround camera systems. So you have 4 cameras, you get that surround system. My latest car has that. So every time I put it in reverse, it shows me exactly what's around the car. And then some of the other manufacturers are adding even more cameras for other features. Highway driving, we can see as many as 11 or 13 cameras on a vehicle. So HFM gives you a great way to package all that in a very compact, very high-speed system. The HFM interface is capable of up to 20 gigabit per second data transfer. So it's significantly faster than the old FACRA. It also helps with things like 5G, as you're getting more data coming in over the air, things for what we call V2X, vehicle to anything communication, all those types of safety systems. The other thing we're looking at are Ethernet-based typically for the in-vehicle communication. And most Ethernet systems today utilize 2 twisted pair. There's a transmit and receive. Well, we've been using a system in automotive for years that's a single pair Ethernet. It's all based around IEEE 803 standards, and you can transmit and receive over the same pair of wires. Industrial actually calls theirs single pair Ethernet, or SPE. And the beauty of the system is the protocols are such that you can use an automotive grade connector on one end, you can use SPE on the other end, and the system can still talk to each other. As we get more into that autonomous safety feature, and I like your comment, the data center on wheels, there's so much data to process that we need those backbones to communicate with each other. The other thing we're looking at is what we call zonal architecture, where instead of wiring every sensor in the vehicle to one separate controller, by bringing it into that zone, what that does is it shortens the wiring length, so you don't need to run long lengths through the vehicle. But then each zone controller uses a very high-speed network to communicate with the other ones. That gives us redundancy for safety features, and it also helps with the overall vehicle architecture. And one of the other things OEMs are looking at is what they're calling the software-defined vehicle. So the idea is you can keep your car longer and keep adding those features that we all like in our vehicles simply by updating software.
So if we talk about that zone architecture a little bit more, the way I understand it is like you're physically carving out zones of the car. Is that right? Like your front passenger side of the car might be a zone, so to speak. So they're like physical regions of the car that you're kind of offloading some of that processing power to, and then you've got a central hub to pull the information back to. Is that right?
Yes, that's correct. If you think about it, there are different safety systems within the vehicle. We've had object detection for a while, which is simply what I term as a dumb sensor. When you back up, it says, hey, there's something there, and it beeps at you. But when you get into adaptive cruise control, for example, you need to know how close you are to the vehicle in front of you, what the closing rate is. So those are much more active systems, and they require more data. But instead of having every sensor on the front of the vehicle come to a centralized control unit, which is typically under the dashboard, that's where most of the high functioning electronics in a vehicle are, those sensors can now be wired directly to the zone controller. There's a simple high-speed backbone that goes between the zone controllers, and that way the zone controllers can talk to each other. And if you have an issue with one of the controllers, the other controller can take over and get the vehicle safely off the road. I've been in the automotive industry for quite some time, and before that I was in the computer industry. And kind of the joke back and forth between them was the computer guys always said, oh, we innovate at such a faster rate. And the automotive guys are like, yes, but if you get the blue screen of death at 80 miles an hour, you literally are dead. It's tough to reboot your car at that speed.
There's the criticality of it. And as you talked there about SPE and power over coax, these are things that we keep hearing in the industrial side of the house too. I mean, industrial cares a ton about safety. They care a lot about pushing similar amounts of data. The speed might be a little different. The weather conditions might be a little bit different when you're only operating inside of a factory. But it's really interesting to hear because we had heard a different guest talk about power over coax as well. It's just interesting how many of these things line up.
And that actually goes back to that beyond the garage message that we started with, because they do have the same issues and it's slightly different environments. If you're working on power over coax for, say, a home security system where you want wired cameras, well, the cameras outside can be interconnected utilizing the Molex products that are sealed, have latching features, and are designed for very harsh environments. Inside the house, you can have the other end of your cable have a slightly less expensive system on it. And the idea is we can offer an optimized cost and performance model for any one of these environments that, again, is not necessarily a vehicle driving down the road. The biggest thing to me is when we talk about interconnect, especially the products that we have, we ask people to think about the environment that you're going to use it in. Start with that and say, is it a harsh environment? Is it just a little bit dirty? Those kinds of things. And then think about the actual electrical requirements you have. I love that DigiKey literally has tens of thousands of Molex parts. But if you're not familiar with connectors, you're lost at trying to find one that meets your application. So I very much like working directly with customers to say, what exactly does it need to do? And I'm able to get it down to, here are the 2 or 3 products that might work for you. And overall, to me, it's a much better experience.
This is a great setup, Kirk, and I'm really excited to connect with you further on this because we are really focused on engineers and designers at DigiKey. We understand that at DigiKey, we've got a lot of parts. It's all a matter of getting the right parts in the right person's hands too. We want to help with that selection part process as well. So I'm really glad that you brought that up, and I'd love to talk to you more about that as well.
And to bring it back to our Beyond the Garage video series, like you said, DigiKey will have links to the current videos. And as we come out with new ones over the next year, we're also focusing on some market segments. There'll be one specific for marine, for agriculture, even around the house, to talk about the different requirements that you might have and also recommend some of the Molex connectors that would fit within that. And everything we talk about in the Beyond the Garage series, every connector that we talk about, is readily available from the DigiKey warehouse. I'm a huge believer in, as a mechanical engineer, I like to have a physical piece I can hold. And the fact that you guys can deliver a part literally the next day, to me is very exciting, because someone can look at it and say, hey, this is exactly what I need. Or they can say, maybe the bigger one would work, maybe the smaller one would work.
So grateful for this time together, Kirk. Thank you so much for being here today. Thanks for the thoughts on Beyond the Garage. I'm really excited to see season 2. How you've been taking this forward it's been excellent. So thank you again for this opportunity, and I look forward to talking to you more in the future about this.
All right, thank you. And the same thing, I definitely look forward to talking some more.